Hello there, my name is Maher Haddad. Today I'm going to show you how to configure redistribution between OSPF, EIGRP and RIP. This is our network diagram. We have router 1, router 2, router 3 connected to each other. Everyone has a loopback which correspond to the router name, like router 1, 1111, router 2, 2222, and so on. And the three are into RIP. And then router 2, router 4 inside OSPF, and then router 4 and router 5 EIGRP, of course router 3 and router 4 also OSPF. So our mission is, we go to the lab. So our tasks are, first we have to redistribute RIP into OSPF on R2 and R3. So RIP has to be redistributed to OSPF on R2 and R3. In a way that the loopbacks for the network 10.0.8/10.0.0/h/8, which are less than /24, should have metric of 50, and it should not be changed from router to router. So these networks over here, which are from less than 24, should have a metric of 50 and should not be changed when they go into OSPF. And the other networks, which are like 1111, for example, like these the /31s, the others should have metric of 100. Then when we redistribute those, they should have metric of 100 and should be changed as it goes inside the OSPF area. So when it's propagated to router 4, for example, 100 has to be shown something else, some other number. Okay, then to do the redistribution, it should be on router 2 and router 3. So I go to router 2, and then the redistribution should be inside OSPF. Then I have to go to, before I do that, I have to create a prefix list. Let's say it a name, for example, or let's put a number, for example, 1, IP prefix list 1, permit, 10.0.0.0, we can put /8 here. So permit this IP and less or equal to /24, and enter. Then over here I have to create a route map. We name it RIP to OSPF and permit, and I will put the sequence of 10, and this route map should match the prefix list, which is IP address, and it's 1. So we see here prefix list of 1. And we have to set the metric. We said that these should have metric of 50 and they should not be changed, so it's metric type 2, and enter. So, and for the others, to say for the other, I have to go back to route map, RIP to OSPF, permit 20, and I will not say match, which means match all others, and then you have to set the metric to 100, and then set metric type to type 1, enter. So if I do now show route map, so what we have here is that we create the first sequence 10 first, then it matched the prefix list, and then it set metric 50 and metric type 2. Then it goes to sequence 20, it matched anything else, and it set the metric to 100 and metric type 1. Okay, that's good. So now I have to go to router OSPF 1, and here I have to say redistribute RIP subnets to redistribute the subnets, of course, and then route map, and our route map name is, it's case sensitive, so we have to copy and paste. It's much better. Okay, and that's it. So now if I go to router 4, if I go to router 4, we see what happens. So router 4, show IP route. Okay, we can see type 1 and we can see type 2. Now, as you can see here, type 2 is for 10.0.0.8 until 24. So you can see that those are from the network 10.0.0.0/8 to 24, and the rest are type 1. Okay, I did it on router 2. I have to do it also. I have to apply this on router 3. So now I go back to router 2 and I will do show run because I have to copy some of the comments from router 2 to router 3. So first I have to copy the prefix list. Do not write it again. So I will copy this one. Then the route map. Yeah. Okay, and then I go to router OSPF and do the redistribution. Router OSPF 1, redistribute RIP subnet RIP to OSPF. Okay, so that is good. So first step is done. Now, but if I do now from router 4, if I try to ping, for example, the loopback 1.1.1.1 on router 1, it should not give me a reply, and the reason why is because we have redistributed from RIP to OSPF, but we did not redistribute from OSPF to RIP. So router 1 on his routing table doesn't know anything about OSPF, and I can show you that. If I go to router 1, I do show IP route. He doesn't know anything about the OSPF network on his routing table. So when you ping from router 4 to 1, the ping go to router 1, but router 1 does not know how to send it back to router 4. So for this reason, we have to do redistribution, and that's step number 2. So they're asking us to redistribute OSPF into RIP with hop count of 8. Okay, so the metric is 8. Redistribution should be on both router 2 and router 3. That's okay. In order to avoid routing loop, you should tag router 2 as 20 and router 3 as 30. You should avoid those tags to go the way back to RIP. This means if I go to the graph here, we have to redistribute from OSPF to RIP with hop count 8, with hop 8, and then this should be done on router 2 and router 3. Now, in this case, sometimes it happened that router 4 redistribute to router 2, or send a routing to route or whatever, any packet which go to router to the area of RIP, and RIP send it back to router 3, and then router 3 send it back to 4, and then you have a loop over here. So what you need to do, you have to tag. This means that you have to put like a mark or a color on the packet. Then if for example router 2 or send when it goes to router 2, then the router 2 put a tag of 20. Then if this packet come back to router 3 and router 3 check that the tag is 20, then it will discard it. He will not let it go back to OSPF. And the same thing here. If router 4 go to router 3, then if router 3 put a tag of 30, then if it comes to router 2 check the tag is 30, then router 2 will discard it, will not let it go back to OSPF. Okay, then also we have to work on router 2 and on router 3. All right, because we are going to do a tag, so I will use also a route map. So I go to router 2, configure terminal, and I will create another route map. And this time I will say OSPF to rip permit 10, the sequence number. Before I do this one, I have to set an access list. So I will keep it now, and I will say access list permit access list 1 permit, and we have to permit these IPs, which are 192.168.24.34 and the loopback 4.4.4.4. So 192.168.24.0, 192.168.34.0, oops, 192.168.34.0, and the access list 4.4.4.4. So this 0, sorry, 0.0.0.255. So this lets me make let only this IP to go into RIP. Okay. So if I do show access list, okay. Alright, I have to cancel this access list and create it again. Access list 1 permit 192.168.24.0 0.0.0.255 34.0 and 4.4.4.0. Now show access list. Okay, now it's much better because we didn't put the white card mask. Now I go back to the route map, which I have created, this one, and now I say match IP address, and here the access list is 1. Okay, and then I have to set, for router 2 I have to set the tag to be 20, and I have to set the metric to be 8. Okay, and then so I do show route map to be sure that everything is okay. RIP to OSPF, no. Okay, this one, OSPF to RIP. So we are matching the access list 1, and we have to set the metric to 8 and the tag to be to 20 because we are on router 2. Okay, now I go to router RIP, and here I say redistribute OSPF 1 route map, which I just created now, OSPF to RIP, and that's it. Okay, so now if I go to router 1, I should have something on the routing table. Here we go. We can see now that 4 is showing, 24 is shown, and 34 is shown also as RIP, of course, because we are redistributing. Okay, now I have to do the same on router 3, and then I have to stop the tagging as we explained before. So what I will do now, I will do show run include section access list. I will copy these ones on router 3, and then I will say show run include section route map. OSPF to RIP, this one. But I will not copy the tag because I need to put a tag of 30 on router 3. So this one, and then I put set tag 30. Alright, this is done, but we did not yet disable the tag. If it comes back to here as 20, then router 3 will stop it, and if it comes back here to as at 30, the router 2 will attack it. But I just want to show you, if I do from router 1 show IP route 4.0.0.0 show IP route 4.4.4.0. Okay, I will do show IP route 192.168.24.0. Okay, if you see here, right here, they say route tag is 20. This means that this route has been advertised by router 2 because we know that the tag is 20. Okay, now how to disable this looping to happen. What I need to do is I have to go inside route map, inside this route map, and I have to put to squeeze number 5, and I have to say deny tag. In this case, I have to deny tag 30. Okay, so I'll go to again to route map or OSPF to RIP, and I have to say deny 5. So I put number 5, which is before 10. Enter. So I will match anything, and I will say sorry, I will say match tag 30. So now if I go back, I say show route map, or let's do show route map, this one to show it better. Show route map OSPF to RIP. Okay, so what I'm saying here, I'm saying that deny, do not let the package which has tag 30 to pass inside this router to be redistributed, and then I'm permitting the access list which we have already done. Okay, I do the same for router 3. I am inside the route map. I will say no, I'll have to get out, and I have to say route map RIP to OSPF deny 5 match tag 20. That's it. So if I do show run include section route map. Okay, it's not the correct command. I have to say show route map, and here I think I did a mistake here. It should be from OSPF to RIP and not from RIP to OSPF. Okay, I will have to kill this one now. Okay, let me check if everything is fine now before I continue. RIP to OSPF, that's fine. So now I have to go back and say route map OSPF to RIP, and deny 5 match tag 20. Now show route map. Yeah, OSPF to RIP, deny sequence 5. Okay, that should be okay now. So what I did now is, now router 2, let's say, is they send the routing redistribution to router 1, and then this comes back to router 3, and router 3 here, we will not let it go anymore because it is tagged as 20. Okay, so this has been done. Now redistribute OSPF to EIGRP, so this area over here, which is router 4, router 5. So redistribute OSPF to EIGRP and vice versa. Note that the network 5.5.5.5, which is loopback of router 5, should not be advertised to OSPF. So this one should not be advertised to OSPF, and 2222 should not be advertised to EIGRP. Also, this loopback should not be advertised to EIGRP. Okay, so let's go to router 4, because all this is happening on router 4. Before I do that, I will show you on router 5. If I do show enable, show IP route, the router 5 doesn't have any routing yet because it doesn't have any redistribution. So on router 4, I have to say, for example, configure terminal, and I go to router EIGRP 1, and here I say redistribute OSPF 1, which has a metric. Of course, you need to put the metric, otherwise it doesn't work. The redistribution 100 bandwidth. EIGRP has 5 Ks, 5 metrics. 5 values to use, which calculate. They use it to calculate the metric. So I have to put them. Delay 1, reliability 255, load 1, and MTU 1500. So if I go now to router 5, I do show IP route again. I should have, and of course I'm having all of this redistribution. You can see that those are from router 1, but because router 1 has redistributed into OSPF, then OSPF has been redistributed to EIGRP, then we can see them on router 5. So I redistribute, but they asked us that this network 2 should not be shown, and to not let this one advertised, I should use something called distribution list. And so inside this router process, I have to write, I think I have to create first access list, but let's check the distribute list, and yeah, I have to create an access list. Then on router 4, I will create access list, exit access list, let's say 15, and I will say deny 2.2.2.0 0.0.0.255, but don't forget to say again to permit anything, otherwise everything will be denied. Permit any. So and now if I go back to router EIGRP 1, and here I say distribute list, and then the access list which I created is 15, and I wanted the way out because it's going out to EIGRP. Now if I go to router 5, and now 2 is shown here, let's try now. It's still there. Strange, maybe it needs a bit of time. Yes, I think, yeah, now it works. So you can see now 2 is not shown anymore. The network 2 is not shown anymore. So we redistribute now OSPF to EIGRP. Then what was the second question? From EIGRP to OSPF, but then the network 5.5.5.5 should not be advertised. Okay. Now, also on router 4, I have to go to router OSPF 1, and I have to say redistribute EIGRP 1 subnets, and of course we have to put the metric. I will put any number metric. Let's say 70 is good, and the metric type, it's by default 2. That's fine. I will keep it like this. So now if I go to router 3, for example, I should see 5.5.5.5 because it has been redistributed, and yes, I can see it. So if I go to the graph, this network has been redistributed to the OSPF. Now my mission is to not let this network show anymore on router 3. So I go back to router 4 and I create again an access list 20 deny 5.5.5.0, and then access list 20 I permit everything, otherwise everything will be denied, because there is an implicit deny at the end of every access list which is hidden. And now I go back to router OSPF 1 and I say distribute list, and the access list is 20 and the way out. Of course here you can put the interface you like, but I just put it out like that. Now if I go back to router 3, I was able to see 5. So let's check now. Show IP route. So you can see now 5 is not shown anymore, but you can see 4.5 is distributed. This one is this link over here. It has been redistributed. Now this step is done, I think. Yes. Finally, ensure that R1 can ping R5. Okay, because on I will ping from R5 to 1.1.1.1, and then from R1 I will ping to 192.168.45.5, which is the serial interface here, because 5.5.5.5 is not advertised because of the distribute list. So I go to router 1 and I say ping 192.168.45.5. Okay, it's not working. Yeah, I just checked now and I show that the reason why I could not ping from router 5 to router 1, because we have created on router 2 and then router 3 an access list to permit only this access list to go into router 1. So if I do show access list, you can see that 3.5 is not allowed to be advertised. So that was the reason why we couldn't ping. So if we cancel this access list and we add 4.5, so let's do it. I say here no access list 1, or let's do it this way. I do show run section access list. So I will copy these. I'll copy those, okay, and then here I say no access list 1, and then I paste this one, and then I say access list 1 permit 192.168.45.000.255 000.255, and access list 1 permit 5.5.5.0.0.0.255. Should be okay now. So if I go to route, I show IP route on router 1. It takes a little bit of time to be shown. Yeah, so we can see now 4.5 is shown, but of course not 5.5 because it has been blocked. So now if I ping from here to 192.168.45.5, it is okay. And if I ping from router 5 to 1.1.1.1, it's okay also. Okay, I hope you enjoyed this lab, and I see you in the next labs.